If you're studying data center technologies using Arista switches, there is a great resource that you can use for free to test features like MLAG, Layer 2 VPN, Layer 3 VPN, EVPN, and much more. The platform is Arista Labs, and all you have to do is to sign up to have access to these labs. You have here MLAG, Layer 3 Leaf Spine, VxLAN, Layer 2 VPN, Layer 3 VPN, and you also can test other features like Cloud Vision, monitoring fabric, network detection response, and even deploying some topologies using code. This platform focuses heavily on hands-on, which means that you shouldn't expect to find a lot of explanation on why they're using the features the way they're using in those labs. Now, if you need to dive deeper into certain topics like MLAG, VxLAN, Layer 3 VPN, then there is another resource, another platform that you can use for that. The user manual is a great resource for you to dive deeper into topics like EVPN. Here you're going to find everything that you need to know about EVPN to be deployed on Arista switches. So for instance, EVPN terminology, different route types, EVPN service models, how to configure EVPN, different example configuration scenarios, and a lot more. So in this video, I'm going to show you how to deploy one of these labs. More precisely, this is going to be the Layer 3 EVPN, but we won't be using this platform because we want to be able to build our own lab, our own fabric from scratch. Now, if you don't have a computer with enough resources, then I do recommend that you take advantage of this platform. It's very good to get started, and you have like 5 hours to use for free. But in my case, I like to learn by doing and breaking things in my own environment. Okay, this is the topology that we'll be using, and it is made of 2 spines and 2 leaves. So leaf 1 and leaf 3. We're not going to use leaf 2 and leaf 4. And there are also 2 hosts, host 1 and host 2. And I've already deployed these on my lab, and if you want, you can download this topology for free on my platform, link on the video description. And so I'm just going to delete stop this because we're not going to use, so just consume resources there. And the only thing I've configured so far is the host name. So let me see the size. I think it's okay. And we'll have to configure everything from scratch by ourselves, and just by looking at this deployment and try to make sense of the things. So let me minimize these. So first thing is going to be spine. Let me bring this here. Okay, so what do we have to do? So let's start with the interfaces. So interface E2, no switch port, IP address 16.201.30, and interface 4. So let's make this a layer 3, 16.209.13, and that's enough. And we have a loopback interface 172.16.01.32, and that's it. Okay, so we know that in this architecture we're going to make the spines as the route servers. So now I can enable routing because we're going to need BGP. And so let's see, what is the ASN for this? So it's going to be 650001. So route to BGP 650001. I'm going to set the router ID, so this is the best practice 32. Actually, I don't need that. And so I believe that's enough. Okay, so I can already start configuring BGP on spine 1, and then we're just going to replicate the configuration for spine 2. So what do we need here? So first, when we are deploying EVPN, we need to set up the underlay network, and in this case we're going to use BGP as the underlay and overlay routing protocol. But first, let's establish the underlay, and the underlay network is going to be made of the IP addresses assigned on these physical interfaces. Okay, so let's go to spine 1. So which means I want to establish a JCC with the IP on those interfaces. So that should be 172.16.202, and ASN is going to be 65101, and the other one is going to be N, and it's going to be a different ASN. That's going to be 65103 there. Okay, so this is done, and because I'm going to deploy the overlay network, so it's going to use the loopback interfaces. So I'm going to advertise spine loopback IP to this one. So it's like 32. That's done, and then I can already start configuring the EVPN JCC as well. So I know that I'll be using the loopback interface, and here I can see the loopback address for each device. So I can say something like this. So network 1603, I don't need 3, remote 65, it's going to be 101. And because I'm using the loopback, so I have to say to initialize this from my loopback 0. And that's not what I want. Update loopback 0. And because I'm using loopback, I have to take into account the number of hops away. And because we'll be using VPN, it uses a different community to send the values. So we have to say to send extended communities as well. Okay, and essentially we're going to replicate this for leaf 4. So it's going to be 172.16.0.5, remote 65103. So we're going to send this from our loopback eBGP and send community extended. Okay, that's great. So now we have to enable these on a different address family, and that's going to be EVPN address family. And we want to enable 16.0, it's going to be 3, activate, and 5. And we're going to disable these on IPv4 address family. So let me remove this. Okay, so let's confirm if I have everything correct there. So router BGP neighbor 72.16.03, loopback 0, send community extended. It looks like it is okay. Okay, so because we're going to have 2 spines, so we want just to enable also ECMP so that it can install 2 prefix in the routing table. So max 2 ECMP 2. Okay, so we are done. So I can grab this configuration. That's not what I want. Yes, so I can take these. So I'm just going to use Notepad to make this faster to change. So I need those IP addresses, I need the loopback, and I need BGP. Okay, so now I'm just going to make the change here and then paste into spine 2. So okay, real quick, what is the topology? Let me minimize this. Okay, so that's going to be, oh, that's wrong there. No, it's not wrong. It's going to be 2 and 4. Yes, so that's going to be 17, and the other interface is going to be 25. I have to be careful here. And the loopback is going to be 02. Don't need to touch on management. ASN is going to be the same. The router ID is going to be 02. The loopback is going to be the same. Now the underlay is going to be different. So this here is going to be 18. And the other one is going to be 26. It's going to be the next IP address. Let me double check. Yes, that's it. Okay, so here I don't have to change. I have to advertise my loopback interface there. Okay, so let me just copy all of these, bring spine 2. Okay, let's make sure that I don't have anything there. Clear and paste. Okay, so spines are ready. So let me bring leaf 1. And let's see if I can also take advantage of these. And leaf 1. So what do we need to change here for leaf 1? Let's get the topology here. Okay, so leaf 1. We have interface 2. It's going to be 2. We have interface 3. It's going to be 17. No, it's going to be 18 actually. And this is done. Underlay. Now loopback is going to be 3. What else do we have? We have another loopback there. Interface loopback 1. The IP address is going to be 1111/32. And we have a secondary IP address 99.99 secondary. Okay, what else? We have loopback, and I believe that's enough. Okay, and then we have, I want to already take advantage, so we have a VLAN there where we have host 1. So VLAN 2001. And what else do I have? So this VLAN will be on port 5. In my case, I'm using port 4. I'll just bring these. So I'm using Notepad. So do I have? I can do it here. Interface E4 switch port. Access VLAN 2001. Okay. What else do we have here? So we have an SVI on this VLAN, and it is inside VRF. Okay, so let's create a VRF instance, VRF1, and now let's go to this interface VLAN, VRF1. IP address is going to be, and you can see that it is VIP, so it has to be a virtual IP address, 172.16.115.1/24. Okay. Okay, so we have SVI, and we have another loopback here. So loopback 901, loopback 901. So this is inside the VRF as well. IP address 200.200.1/32. Okay, done. So I believe we can now focus on BGP. Okay, but before that, because we created this new VRF, we also have to enable routing inside this VRF. So that should be IP routing VRF1. Now let's go to BGP, and BGP, that should be 65101. Yes, we are right there. And the router ID, that should be 172.172.16.03. We're going to leave these. Now, a couple of changes we have to make here, because for underlay, we're going to use from leaf 1. That's going to be, let me change here. It's going to be 1. So it's going to be the first IP, and the other one is going to be 17. So let me change here to 17, and they'll be using the same ASN. If I'm not mistaken, let me check that. It's 650001. 001. Okay, so this is going to be the underlay. So now I can make changes here because that's going to be the overlay. So this is, let's suppose this is going to be for spine 1. So remote AS is going to be 650001. So the update source loopback 0, eBGP multi-hops, and community extended. Now for the other one, that's going to be 2. So let's just change here to 1, loopback 0, eBGP multi-hop, and send community extended. And we're going to enable also EVPN. That's going to be for neighbor 1 and 2, so both spines. And we have to disable these on address family IPv4 for 1 and 2. Now we're going to advertise our loopback, so in this case is 03, plus also these networks there. So let me just, didn't want to do that, but anyway, so that's going to be 1111/32 network, and the other one 999.99.99.99.32. What else do we have there? Nothing more. Okay, so loopback 0, loopback 1. Okay, got it. So I believe we have everything there. If not, let's double check here. I'm going to copy these and let's just paste to leaf 1. So what do we expect to see at the end? We should see BGP adjacency with both spines for IPv4 and also for EVPN. So let's see first. So IP BGP summary, you should see 2 adjacencies established. Okay, and that's what we want to see there. And I should also receive 2 prefixes, so 172.16.01 and 172.16.02 from each spine. And if I have those IP addresses on my BGP table, it means that I can establish the EVPN adjacency as well. So I can check that by run show BGP EVPN summary. Okay, we can see it is established as well, but at this moment we don't see any prefix sent or received. Okay, so we know for sure that BGP underlay is operational, overlay using EVPN is also operational. That's great. I can already start configuring the VxLAN part that we're going to use to get the information from the host and send it into VxLAN, and then it's going to be sent across EVPN to the other VTAP. So let's start doing it. So interface VxLAN 1 and VxLAN source interface is going to be from loopback 1, because you see here it says VTAP. So VTAP, that's going to be the point where this leaf is going to use to encapsulate and decapsulate VxLAN packets. Okay, so VxLAN using source interface loopback 1. VxLAN, so now we're going to make the mapping between the VRF and VNI. So in this case, it's going to be VRF1. And VNI, we're going to use a random number. I'm just going to use the same one that I saw on this lab. So that's going to be 1001. And it's done. Now, another thing that I noticed during the lab, and this is because the VxLAN header is going to increase the header. So we're going to increase the MTU on interface VLAN 2001, and the MTU there was jumbo frames, and we also have to enable these or disable no auto state. Okay, so that should be enough. So we have VxLAN, we have our interface, we have, let me double check the interface 4. Yes, that's done. So now we can import those prefixes that we have in VRF1 into BGP. So let's go to BGP 65101. Okay, so VRF1. So first we have to set an ID, a route distinguisher ID, to tell, okay, this is the leaf that is going to be importing the prefixes on this SVI into BGP. Okay, so route distinguisher, let's use 11111, and we're going to use 1001 as a reference. And now we have to use the route target to tell, okay, in this VRF we're going to import based on these values. So if we have the same values at the other VTAP, it means that it's going to belong to this MAC table. So in this case, we're going to use the command route target. Let's suppose to import to receive from the other VTAP EVPN, and let's use this value and to export we're going to use the same ones. Okay, and I just want to inject those prefixes into BGP, so we can check that by using the command EVPN. Okay, so that's great. So these are the prefixes I'm injecting into BGP, so coming from leaf 1. Okay, so now let's do the same on leaf 4, in this case leaf 3. Okay, so I'm just going to grab all of these we did here, and we're going to make some minor changes and deploy on leaf 3. So let me go here, leaf 3, let's go layer 3. Okay, so change this here. Okay, so first thing first, VLAN, I believe that's 2003. Okay, so the VRF is going to be the same, the IP address, so that's going to be 10.02. For 03, that's going to be 26. For interface 4, that's going to be 2003. So I don't care about 5, 6, 7, and 8. Loopback 0 is going to be 5. Loopback 1 is going to be 333. The primary address, the secondary is going to be the same. Now for interface loopback 901, so that's inside VRF1. IP address, that's going to be ending with 2. We're not using interface management. Now here we use interface VLAN 2003, and the IP address, that's going to be 172.116.116.1. For VxLAN, we're going to use loopback 1. VRF VNI is going to be the same value. IP routing enabled, and also for VRF1, the ASN is going to be 65103. The router ID is going to be 1605. So for overlay, we're not going to change these. We just have to change here underlay. So for underlay, that's going to be 9. So that's going to be spine 1. And the other one is going to be 25. It's going to be spine 2. For EVPN, we don't have to change. Now inside IPv4, so the IP address that we have to advertise in our underlay is going to be 3333, and here the loopback has to be 05, and I have to be careful there. Now inside VRF, we're going to change the router ID to be 333. At least we will know that's leaf 3. The route target values is going to be the same, and we're going to inject all the networks into this VRF. Okay, so it looks like everything should be just fine. I'm going to copy these and bring leaf 3, and just make sure that I have everything clear, and paste. So while it's loading, I can bring host 1. So host 1 interface, we're going to make this a layer 3 interface. If we look at topology, that should have the IP address 172.16.115.100. We're not going to use port channel. I'm just going to disable layer 2 and make it a layer 3 port, and assign the IP address 172.16.115.100/24. Now if everything is okay, from host 4 I should be able to ping 172.16.115.1. okay, and I can. That's great. So we know that we have communication between host 1 and leaf 1. Now I'm going to make this IP address as my default gateway, so that I'll be able to reach host 2. Okay, so IP route 00072.16.115.1. And do I have to enable routing? Probably. Let's just enable it, and it's done. Okay, so let's do the same on host 2. Okay, so host 2, that should be interface 1. Yeah, interface 1. It didn't change. Okay, no switch port, IP address 172.16, 116, 100/24. Let me double check this. 172.16, 116, 100. Yes. So if we ping 172.16, 116.1, okay, we can confirm that. So let's enable routing and make this 172.16, 116.1 our default gateway. Okay, and 172.16, 116.1. Okay, so far we know that we have underlay, overlay established. We have reachability from hosts to leaves. Okay, so before proceeding, let's just confirm that from leaf 3 everything is okay. So let's run the command first, show IP BGP summary, and we should see 4 prefixes being received and advertised with both spines. That's great. So now let's confirm that we have also JCC using EVPN. Okay, it's established, and we have 2 prefix received and accepted. So what happened? What we check here? Okay, that's great. And we are receiving the prefixes from leaf 1, and here we see 172.16, 115. Okay, so we're using here, there are 2 options, and also the 200s coming from leaf 1 as well. Let's double check that we see the same information on leaf 1 before testing reachability from the hosts. So show BGP EVPN summary. Okay, 2 prefixes there also. Let's take a look, and here are the prefixes coming from leaf 3 as well. Okay, it looks like everything is okay, and we should be able to reach host 2 from host 1 or vice versa. So let's go to host 1 and ping 172.16, 116, 100, and it's working. That's great, man. So we have reachability between these 2 hosts using VxLAN using EVPN. That's great. So let's confirm some output right now. So for instance, show IP route VRF1, and we can see here that we have information about this prefix, this network via VTAP 33, VNI 1001, router mic coming from VxLAN 1. That's great. I believe we can show IP ARP VRF1 172.16, 115, 100. So if we go to host 2, is it host 2 MAC address? Show int 10185. No, that's not. Ah, that's 115. This is local. That's not 16. Okay. I think it's, did it expire? Let me check this real quick. No, I can't see here. That's not a problem. Okay, what else can we check here? BGP, EVPN. Let's see, route type, IP prefix. I won't get much more than these, right? IPv4 detail. Okay, let's see. 16 route distinction. Okay, so metric, it's valid external. This is the best. And yeah, extended community route target. Okay, so everything seems to be working just fine. So this is it, guys. Quite simple, quite easy to deploy EVPN, VxLAN EVPN using that symmetric mode, deploying these on Arista switches. Again, if you want to get this topology, it doesn't have the config. I don't save with the configs. You can get it directly from my platform. Also take advantage of those platforms, those resources that I share, and it's going to be in the video description as well. If you have any doubts, let me know. If not, don't forget to subscribe, hit the like button, and I'll see you on the next one.